कॉपी वगैरह बाद में ये लिखा पढ़ी कर लेना, आप एक एप्लीकेशन लिख के फिर
हाँ
वो
बस
कर
वही
लो, फिर
करूँ
गेट पास नहीं है।
यार, ठीक बात है।
Hello? 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 यूट्यूब पे शुरू हो गया। यूट्यूब पे इन्होंने लाइव डाल दिया है और ये यहाँ से वो रिस्पॉन्ड को नहीं कर रही। हेलो?
Hello, sir. Okay. Piyush, sir. Hello. Sir, now you can share your screen, sir. We'll check it. Hello.
Hello? Yes, sir.
Sir, you are audible. Sir, now you can share your screen, sir. We'll check it once.
Actually, the voice is not coming in my mic.
The voice is good, sir, actually.
Voice is okay?
Yes, sir. Yes, sir. Voice is okay.
So hello, sir,
Yes,
in
sir.
share
Tell me,
screen,
sir. Please share the screen.
there are options coming, whiteboard. I can share my screen.
Yes, sir. Share screen. Yes, sir. Now, yes, sir. Your screen is visible.
Something is happening, na?
Yes, sir. Yes, sir. Your screen is visible. Yes, sir. I can view your PPT.
Okay, now audio is also there and video
Yes,
is
sir.
also
Audio
there.
is there. Video is also there, sir.
Okay, now I can just minimize this and okay, sir. I think it is okay now. Everything.
Yes, sir. It is okay, sir. No problem. It is okay.
Okay, so
I'm 11 o'clock, sir.
I'm just unmuting myself, muting myself.
Okay. Okay, sir.
At 11 we will turn on again.
Sure, sir. Okay, sir. Thank you, sir.
Hello.
Hello, sir. Sir, just 2 more minutes, sir.
Yeah. Am I audible properly?
Yes, sir. You are audible, sir.
Okay, sir.
Just 2 minutes, sir. Participants
No problem,
joining.
no problem.
Just 2 minutes will
No
wait,
problem.
sir. Thank you. Sir, shall we start, sir? Piyush, sir.
Hello. Yes, sir. Yes, sir.
Yes, sir. 1 minute, sir. Date. So good morning, all the participants. Welcome to the webinar on utilizing micro hydro systems for quality electricity generation. Today's resource person is Dr. Piyush Pant. Dr. Piyush Pant did his PhD from University of Delhi, MTech from IIT Delhi, BTech from KNIT Sultanpur with specialization in electrical engineering. He has 18 years of experience in academics, research and industrial organizations. He has published 19 papers in reputed journals and conferences and has 1 patent. Currently, he is working as professor in Bhagavan Parshuram Institute of Technology, Delhi. Thank you so much, sir, for accepting our request and coming as a resource person. Over to you, sir.
Thank you very much, sir, Kiran sir, for my introduction. And I welcome all the participants for sharing your time in this webinar. And the topic of the webinar is utilizing micro hydro systems for quality electricity generation. So I would like to give my introduction as already sir has given. I'm Dr. Piyush Pant and I'm the professor in BPIT Delhi presently. And we all are living in Delhi, and mostly people of all across the country have joined here. But in Delhi, I would like to say that the weather is very unpleasant. Lot of dust particles and pollution is in the atmosphere. And it is the issue that we have to think today and for the future also. And by and large, this I am saying because our target for tomorrow, technology will be based on all these factors. So as far as this discussion is concerned, so my aim is to discuss here about the small capacity generation by harnessing the sources, actually those which are in the form of small rivers. They are the form of canals. They are available everywhere and have the electricity which is frequently available to us. And we say them as a pico hydro systems, micro hydro systems, like that. And we have to generate quality electricity from them. The electricity can be utilized for the isolated locations and also for grid coupling. I think that few of you are quite not familiar with this. Some of the people, maybe the electrical people, engineering people, electronics people who are quite familiar with these all terms. But if we say that what is electricity and what is quality electricity, so this is actually becoming a very important term in today's life. Actually, electricity is selling as a product for today. If we want to generate electricity, it should have the proper quality, like the bottle of Pepsi, like the wafer of Lay's. If the quality is not proper in that product, so the consumer will not accept it. Similarly, in the deregulated market, what is happening that the electricity we want to produce should have proper quality. I would like to tell you in the next few slides that what actually the power quality parameters are, but just you must understand that if you are not, if the generator side is not supposed to maintain such parameters, then nobody is going to accept that quality. And now we have the two different sectors. One sectors are the places for the overall growth of any country or any location. It is very important that each people, everyone should have accessibility to electricity. Now, it is not every time possible to erect electricity grid. Many of us are familiar that we have the villages where electricity grid is not present, even though we have to arrange some form of lightning arrangement for them. So that location are called the isolated locations, where no term of electricity grid, no electricity poles and lights and anything is there. But how they people will be fed? So they have similarly the different type of the arrangement. And second thing is that it is called the grid coupling, right? And grid coupling is actually the grid we have available. Suppose for an instant, we say Power Grid Corporation of India. It is one of the important body of government of India, which is handling how the electricity will be transmitted from north zone to south zone or any part of our country, or we have to transfer that electricity to other countries also. So that is one of the things. So grid is very rigid thing. Grid has enormous amount of the power which can be delivered to the consumers, to the industries. But isolated consumer are different one. You can see that some people is using the solar panel and he is getting sufficient electricity to light his or her home or some any other application. So this is the difference actually. And as far as the technology is concerned, so there is a in words, it is very simple to say isolated applications, grid coupled operations, and quality electricity. But as far as the development of technology is concerned, so it has taken already many years to come to this level and to utilize some new source and to generate such quality with that. So in this session of webinar, I would like to give you discuss some of the introductory part of it, that why I am advocating this micro hydro. Actually, micro hydro is likely the new term for many people for us. And then we will discuss that how the in isolated location, how we can generate the quality electricity. And also we will discuss some point that how the grid coupling can be done. See, these are the point, actually they are under research also, they are implemented also. If we talk about the engineering and technology peoples, like we are the students here, some people are faculty members, some of our industry people, some of our users there. So they have their own level of working. A student can think about that, what should be the scope that we can develop new sites where the electricity can be generated. Technology person can have to develop that in the form of the product type. Then third category of the users, he will say, yes, give me such electricity, then I will use it. Or I have the instrument which is not able to work on this voltage you are providing us, so I am not able to take this voltage. Or he will say, yes, your power is very good, you are the very good user. So in country like US and Europe, now they have actually driven towards the competitive market. We will have 2-3 suppliers in your home, and you have the ability to check, like in your mobile phone you do that, you have different type of the sim supplier company, and they will give you the sim, and if you are not getting the good service, you change that sim. Similarly in electricity also, this will be the future, that we will have different 3 or 4 companies will be there, and they will be providing you electricity. If somebody is not able to give you 24-hour electricity, then you will say, no, I am not interested in your supply, because I am not getting the supply in the proper manner. If you are not getting 24-hour electricity supply, so why you have to pay money for that? You can claim it in that time. Different type of the things are actually available in the globe, and the future is that anytime after 5 years, after 10 years or 20 years, we have to face them in our country also. So obviously for this these things, the motivations actually goes to the fact that presently that I was starting at the starting of my in this seminar, I was saying that the pollution in Delhi is too high. The reasons are many. We cannot cite any one reason, but as far as this uh, slide is depicting you, and in YouTube, I think the slide has not been changed, but uh, this slide is actually depicting the sense that we have to generate electricity by more dependency of renewable energy resources. This is actually the future of electricity. There are many countries in the world which have turned themselves toward renewable energy. And in the simple second part of the slide, where you can see that how the world and India are utilizing or generating the electricity they have. See, the data percentage can be changed. This is a data for, I think I have, when I have collected this, new installations are there. But this is a tentative, actually, the distribution, that most of the power which is in the globe as well as in India, you can see that it is coming for fossil fuels. Second option is the hydroelectricity. It is one of the important generating systems which are contributing for electricity generation. See, and the third one are the nuclears. And anybody of you can tell that what is the problem with fossil fuel. The very first thing is that they are depreciating day by day. NTPC, they are not having sufficient amount of coal to burn it and generate the electricity, and that is actually the future also. How, from where we are getting the coal? Simple thing. Hydroelectricity, these type of the projects are actually very time consuming. They require a lot of economic factors also. You can say that the hydroelectricity plants have the very long gestation period. It takes 20 years to complete the project. Maintenance is very issue. So again, the things is not quite practical. We can see only in India also, we have not developed so much hydroelectricity plant in after our independence, which were developed are not operating at full load. There are technical problems, there are economical problems, there are political problems. You have to rehabilitate the things, that are the issues. Third one is the nuclear. What are the issues with nuclear? Nuclear. Japan was one of the country which was depending upon the nuclear, but we can always get the data that nuclear, if it is harming the mankind, so what is the use for generating that type of the power? So people are not going to motivate by the nuclear power also. So what left? What left in both of the graph, globally as well as in India? Only the renewable. And you can see this type of the figure what I'm showing to you will be it will be grabbing more area on this graph after, and years by years renewables will be coming into picture. And I would like to cite the example of country like Denmark. Last 2 years they were generating 45% of their total consumption with renewable energy, because the reason is quite simple. For tomorrow, if our aim should not be only to generate electricity and to develop the equipment which give our comfort. Okay, we have to run our AC also, we have to run our heaters also, we have to run our industries also, but not at the cost of this pollution and cutting our trees and disturbing our environment, because for future our children have to live there, they have to survive on the same country. So this is actually the requirement of the future, that we have to be more give emphasis on renewable energy resources. So what are renewable energy resources? It is actually quite burning topic from last 10 years. Lot of investigation research is also going on. If you see the good publications and anywhere publications, those who are doing research, so most of the peoples are focusing there towards the renewables energy sources. But if we talk about the renewable energy, so what renewable energy? Solar, we can say solar, it is a renewable energy form. Wind energy generation, it is a form of, again, the renewable energy source which can generate electricity for us. Good work is going on, good research is going on, quite plants are also there. But I have tried to give you in this slide something about that new idea, that how this micro hydro type of systems, pico hydro systems, which we can exploit the energy by utilizing our rivers, our small canals, which are naturally available to us, can have the very good potential to develop electricity. If you see in these 4 graphs, so if somebody want to generate electricity in some rural area, so first option he has simply is the diesel generator. Diesel generator, what is a very bad where diesel generator is not getting good marks? Because its environmental effects are very bad. It is polluting the atmosphere. You are burning the diesel or the petrol, so that the things are not okay. Second is obviously the fixed and running cost. We can see that in some places the petrol diesel cost is rising day by day. We are not having sufficient petrol for vehicles, so how for our diesel? So it is not actually the solution, permanent solution to generate electricity. Second, we can go for solar PV, right? Solar PV, again, in the second right corner you can see that what is in the solar, the energy storage requirement. The solar is lagging its marks in energy storage requirement. That means the solar systems which are existing today have not capability to generate electricity in night times. Somebody of you might not have about these terms. I would like to give you the recent research that after 20 years, the solar, after even 10 years, 5 years, if the research will be sufficient, then we will be having the electricity from solar in the night time also, because radiations are available. But in today's scenario, whatever the solar systems we are using are not so much capable to give us electricity in night area. So what we have to do in nights, actually we require the lightning, we have to study in night times, we have to run our television sets on the night time. Most of the work at till 11, we need the electricity from 6 to 11. So what is the solution? Simple thing, we use the battery, no other thing. Battery is very hazardous. If you go through, one of the important thing of technology is the hazardous waste management. I'm not talking too much on this thing, but it is one of the burning topic of today technology and political side, that hazardous wastage, all the electronics wastage, all the computer chips and mobile phone, it is very difficult to handle all these things. They have the heavy materials, and how to dump them, how to extract actually the material which is available on them to form the real product. because even if you can imagine yourself, you have anybody of us changes in his mobile phone in 2 years or 3 years, so the old one becomes the hazardous waste. Okay, similarly the battery, what is in the solar PV is a hazardous waste. They have the assets in itself, you put it in the ground, it will be wastage, so it is not actually the good solution. Second, solar PV, anywhere you install, you have to clean its surface properly, you have to clean the surface solar, otherwise its efficiency will be removed, not be as good as it was designed actually. So it is cumbersome work. And even for the large applications where any industry is coming into focus and they are maintaining it, their manpower, deploying dedicated people for it, it is okay. And even I am saying that it is one of the good promising source of renewable. The third one, you can say the wind generation. Again, the issue with the wind generation is energy storage requirement, because what is in the wind? Wind, sometimes wind is available, sometimes wind is not available. You have to control the pitch angle. The wind turbines are there. You have to synchronize them. Otherwise, your power will be fluctuating. We can say that power electronics technology is there which can regulate all these things, even though some person for his personal use is not interested to install wind generation for his requirements, you know. So from that point of view, I would like to advocate pico hydro systems. What our basically the topic is, pico hydro means that I have given you the example that a small river is there in your locality. You can just put the generating system, float the generating system there, and you generate the electricity for your house, for your two house, for your neighbors also. You can sell that electricity also. One thing, it is reliable actually. Reliable means a river is there, it is flowing in the day also, it is flowing in the night also. You can get the, you cannot say that tomorrow the weather is not good and you will not get the electricity. Such type of the forecasting is not required there actually. It is continuously available. Reservoir requirements are not there. Reservoir requirement is for big hydro systems where our big generation is there. But for small hydro, naturally what the river is, we can utilize that thing. Battery storage requirement can again be eliminated, and we can go for the cost effective generation, because if all the things are involved there, so the things will naturally cost effective. We can generate our electricity at the very minimal cost, only the installation cost will be there, and few amount we will be in the maintenance. Otherwise no such thing will be there, and it is very robust actually. I will cite something. I will give you the example that how we can make it robust. You just throw it in the river and you can generate the electricity. Okay, so as far as if I'm saying that micro hydro projects are there, so one important thing that is emerging is that if we take the example of only our country, that is India, so there are a lot of promising scopes the micro hydro projects have. Like, you can see the list of different states. See the potential. Andhra Pradesh has potential of 497 such micro hydro which are identified. They are identified by Government of India and different agencies. Arunachal Pradesh 550. You can see the list. Kerala 245, West Bengal 203, and they have the very good potential to generate the electricity. Right? If you accumulate them, so in India we can develop 5,718 till date. What are the potential that government has cited? That after the good civil engineers go there and they propagate the site, then they say that yes, this is a place which is okay, and we can develop some systems here which can generate electricity. They are actually Ministry of DST is also working. They have the separate department for micro hydro also, and they identify after many consultations such type of the potentials. But the thing is that how many projects are installed and how many projects are under implementation. Project installed, they are quite less in numbers. You can say that if we can just take the example of Andhra Pradesh, so almost 500 projects have the capacity to install, but we are not even lying on the range of 60, 63. That means even 10% are not installed, and installation is going on very less, right? So when such thing is happening, so why this happens actually? Do you know the reason that if something is there and it is not happening. If something is possible, but it is not happening. So what is there? There are some bottlenecks, some issues. Something is there which is obstructing the development. In every state, you can see that lot of potential is there, but project installed and implementation are less. So I would like to give you that the figure that how this type of the system will look. See, if you can see in the places where micro hydro projects are installed, so they are very small in space. Just small motors are there, and I am talking about the system which are 10 kilowatts, 20 kilowatts, 50 kilowatts, like that. In our home, I would like to say that the 5 kilowatt electricity is quite sufficient. In Delhi apartment, they are providing 5 kilowatt electricity for all. We can run two ACs and some more appliances in our home with 5 kilowatt for Delhi itself. But if the area is rural, 1.5 kilowatt, 2 kilowatt is sufficient. So for a single unit can uh, give sufficient amount of the power. This similarly, they are the different figures where the things are installed, and they are quite not big installations. Not they will look like in particular industry where you have to install all these things. But our challenges which are coming in the micro hydro, that I was citing you the thing that in each of the state the things are not quite motivating. The reason is that we have to check that in the places where the micro hydro system are installed, so what were the issues. So I have taken some examples that Thalupalli micro hydro power project, it was 20 kilowatt power project, and it is operating in Tamil Nadu, right? And the issues they were facing is that it is a site specific technology. You have to put the roads also there, you have to put the machine arrangements there. Sometimes the uh, some disturbance occurs, so there should be the accessibility of the person who can reach there, and they are confined to specific type of the loads. I will tell you that what are the issues concerned, but specific load means only you can run your electricity bulb. If CFL there, it will not run, it will not operate. But if the incandescence bulb is there, it can run. So if the technology is tending from incandescence bulb towards the LED bulb, so your generating site should also cater its requirement. But right now it is the issue with them. Second, Nepal has 150 stations, but they have not scope for their energy expansion, right? We can see in Rwandan hospital, they are supplying electricity to their national grid. They are looking to generate, but the grid coupling issues are there. Whenever any fault occurring in the grid, it is affecting your small generator. Your generator is very small, 5 kilowatt. Grid is very huge. And if you are connecting with it with a grid directly, so if any problem occurring in the grid, it is affecting also your small generator, which is of 5 kilowatts. So again, you have to maintain it. You have to put somewhat your money to maintain that. It becomes the issue again. That grid coupling is there, and they are not immune to fault. Actually, fault immunity is the very important term nowadays. Something happening, your generator should uh, remove itself from that issue. It should sense that thing, and it should remove that thing with there. Also, I would like to cite that many in across globe, many private-led companies and government-led companies in Tanzania, Kenya, Rwanda, they are all African countries. Many international giants are also went there, and they have installed these systems. But they all are basically working on the fixed excitation control, because in the electrical technology, we have to give the excitation to the generator, and we have to run the turbine, and then we can generate the electricity. But if that excitation is fixed, so your voltage and fluctuation, if it is happening with the load, they all are actually not controlled by the user, and that is actually causing the transients, or they are actually not good. So these are some major issue, and last seasonal variations are there. So these are actually the things are facing. So accordingly, my aim is to address these things, that how, what are the few things that I have also understand in my work, in different research work in different industries, that what are the issues, and that I would like to share with you. and obviously according to your working, you can work on that side, you can find interest on them. So the very first thing is that whenever we are generating the electricity, the very first fundamental that was proposed is that in magnetic field, if you run any prime mover, it will generate the electricity. That is basically the function of a generator. And for micro hydro, we can prefer synchronous generator. We can prefer DFIG. It is a doubly fed induction generator. This is the third one is PMG, permanent magnet generator, switch reluctance generator, or we can use the induction generator. I would like to make you clear that these all are generator also have particular research scope in itself. Synchronous generator, it has to be run at fixed speed. If the speed is not fixed, there are many concerned issues in the generator. Its frequency will disturb actually. DFIG is a big generator. It is doubly excited machine. You have to give DC also. Permanent magnet generator, you have to provide the excitation, and some complex technology is available in PMG and SRG also. And induction generator, actually self-excited induction generator, they are basically the main generator which are implemented in existing systems, and there is no issue with the induction generator if we utilize the generator for electricity generation. So this is one of the good generator which is existing and requires less complexities for its operation, because overall the purpose of the technology is you must provide very simple solution for your users. It actually the requirement of any people who are working in computer side, those want that the app should be very easy for the consumer. We use Uber app, so it just asks you where you have to go, where you are going, where you have to go. That's all. Nothing nonsense. Similarly, our generator should be very easy, and from that point of view, I would like to advocate induction generator for micro pico hydro project. So what is induction generator actually? Induction generator is simply the induction motor, you can say. It is a 3-phase induction motor, or you can use single phase induction motor also, but my emphasis is to work on 3-phase because it is very having some good parameter in itself, balancing and many other issues are there, and sometimes our load is also 3-phase, so they can cater that type of the load also.
All the participants, please wait 5 more minutes. Maybe resource person has corrected.
Piyush sir, now you can check sir. Sorry, participant, please wait for 5 more minutes. Sir will rejoin. There is a network issue at the sir side. He will rejoin in 5 minutes. Piyush sir, no mic sir. You are joined plus, but mic symbol is not there.
Hello.
Sir, now you are audible and visible, sir.
Yeah, is it okay now?
Yes, sir. Okay, sir.
Okay, so I go ahead.
Yes, sir.
Sorry, there was an interruption. I don't know. It was a technical fault, so you have to bear. So anyway, I was discussing. We are looking over the facts accessibility. Accessibility means today I go to the market. I will ask the people that give me an induction motor. He will immediately in 5 minutes he will give me induction motor. For other motor we have to give orders, or even they are not as easily available, so that is the issue. Second is the cost effectiveness. It is one of the motor which is available in least cost actually. uh, it is also the motor which is mostly used in the industries, induction motor. Third one is the robustness. It is the robust motor with the different say effects, and with the different atmospheric changes, different chemicals. These type of the motors are not affected very badly, and they go on working. They have the brushless rotor, and the structure is quite fault immune. Technically, if some fault occurs, some unbalancing type of the issues come in the motor, or some transient currents are there, so they can easily uh, absorb it, and they are quite termed as the fault immune structure they have. So this is one of the things that about the motor, that induction motor I am saying to be a best suitable motor till date. Even the research is going on, and in future the technology will be different than today, and we can be able to use some other motor also. But for today's technology, I actually advocate induction motor. And second, now the important term is what is power quality. Now, please, if I say that generation of the electricity can be done only by revolving a rotor in a magnetic field, you will generate the electricity. Or you can see that some voltage will be developed there, some frequency will be there, some oscillation. Is that electricity usable for the load? The answer will be no, because anytime when you see the electric bulb, there is a voltage particularly written 220 volt, 50 hertz. If you are not giving it twice, the bulb will be 50 volt. By over voltage, it will get damaged. If you will give it 200, 180 volt or 170 volt, so there can be the different type of the issue we can see. So for the consumer point of view, he need quality electricity. That also something I have discussed in the first point in the priorly in this seminar. So what are the power quality parameters? The very first
Sir, Piyush, sir, you have no mic, sir. Sir, Piyush, sir, you have no mic. Sir, Piyush, sir, you have unmute yourself, sir.
Hello, am I audible?
Yes, sir. Sir, it's audible, sir.
Am I audible, sir?
Yes, sir. Please continue, sir.
Okay, sorry, there was some regular interruptions, and in case of power quality, we have to check what is our frequency we are generating. It is very important actually. In India, our frequency is 50 hertz, and for grid point of view, different grid regulators, they are maintaining this frequency by asking the generator side that what operation or what technology you have to make, or at what speed you have to run your generators, or to put the load, so that it should be maintained. But as far as if we are working in some isolated manner where nobody is there to regulate us, so how we have to control the frequency? It is the important thing. Our voltage which is generating by our generator should be fixed, it should be constant. There should not be any disturbances on the magnitude. There should be no flickers. Actually, flickers are that they are the disturbances in the voltages. There are some voltage sometimes up, sometimes it downs, and type of the flickering we get. There are the voltage dips, swells, voltage interruptions are there, and harmonics. They are technically come from the operation of power electronic devices. So they should also be controlled. So at least for minimum these parameter regulation is our duty. Mic is not coming, sir. What? Audio?
Yes, sir, it's audible, sir.
Problem in audio, sir?
Sir, no problem, sir, it's audible.
Sir, may I know some issue? What is the problem getting? Hello.
Sir, it's audible, sir.
Okay, sir. Everything okay, sir? Okay. So, hello.
Yes, sir.
Hello.
Yes, sir.
Yeah, Kiran sir, I do proceed.
Yes, sir. Proceed, sir.
Okay. So there are few disturbing power quality issues in micro hydro generation systems. They are just been on your board. We can have the very big disturbances with the turbine side. Whenever any any issue or any debris which come to the turbine side, it call the disturbances, and that disturbance will cause the disturbed voltage and frequency. We can have the large voltage, low voltage ride through capability if not okay for a system, then we can have the disturbance. The third issue that can be there is about the starting operation of induction motor. Induction motor during starting draws a lot of current actually, and if that current is transferred towards the generator side, so it can cause its overloading also, and transient overloading actually the issue. And we can have the intermittent constant power loads. These are actually different type of the loads in the SMPS power type of the supply, charging of e-vehicles. Ultimately, we have to use that type of the load also. So we have to cater the things such that the constant power load should not disturb the generator. So as far as now our discussion second point is concerned, so it is the isolated operation. So what if we are operating the generator with micro hydro system coupled? So in isolated case, what should be our strategy? What are the methods I'm proposing you? Because modern electrical loads like SMPS, e-vehicles, constant power loads, they are actually the modern electrical power loads, and they are very much applicable to the rural locations. For example, I can say that e-vehicles are required to be charged in remote locations also, where your road is there, you have to do some arrangement to charge electric vehicles. We have to give the computer to the people who are in the rural locality also. We have to develop that children also. So from that point of view, the challenge is, what are the challenges we have to face to develop the control algorithm for voltage and frequency regulations. Now, control algorithms are completely developed with the help of communication engineering as well as computer part and power electronics switching of the systems. These systems are very important, and they have a very important role if we want to develop quality electricity, because better the control we will do, better our we can say the quality of the power will be there. Establish generator to feed constant power load without observing the voltage collapse. The CFL type of the load should also be catered. We can start induction motor in effective manner, and we have to develop the solution for voltage sag recovery, low voltage right through, and fault immunity type of the systems. So these are some of my suggestions that was basically the aim of this seminar, is to develop some solution, to propose some solutions that how we can generate the quality electricity. Quality electricity, I have abbreviated many terms. It should have constant frequency, constant voltage, constant flickers. So it actually required that what type of the load we are using. Suppose I can take the example of simple electric heater. I have to do electric heating. From that point of view, the big harmonics and things are not the concern for me. But if I am running some electronic medical devices, there the harmonics and frequency will play a vital role. So this is the point which are required to be concerned with the engineers, that what issue should we take, so that we can get the maximum utilization of our things, and we can get better quality power. This is the technique that I am proposing to match the real power of micro hydro system with grid connectivity provisions. So the aim actually is that whatever the power the micro hydro is capable to generate, it should be transferred toward our load anyway, and the system should have also the provision of grid connectivity. Suppose in future that particular isolated location will having the electricity grid proposed by the government. So our system should be connected with this, and at the starting level we can give the provision for that. And this type of the very good example I have thought about it. We can propose the effluent treatment plant on the rivers. Effluent treatment plant, whatever the people throw in holy rivers, and many things, our restaurants and our many places which put the garbage on the rivers, they should also be treated as a effluent, and our motor will be run, our generator will run, they will treat it by that centrifugal action, and finally the water will be treated. So it will be the good example if at micro level such type of the system will be operable, and we will get the treatment of the rivers like that. So in that case, we can see that the flow rate of effluent is fixed, and it is offering the constant head. Minimum hardware approach for cost-effective solution to induction generator-based generation at near constant frequency by matching of connected load with the generated power. I am matching the load only for the purpose that in case anything our load is not attached, so generator should not having surplus power to deliver, because if in case the surplus power will become, the generator will be come to the over speed, and its voltage will also increase. So we have to take care of the fact that the power should be maintained. But energy balance, actually this is the theory behind it, that whatever the power we are generating should be in the losses and go through the load, that we have to maintain in every place, either it is the economic place, income we are generating, if we are delivering it in the suitable representation, then the things will okay. So this is actually the configuration that I am proposing, and here we can see that this is a micro hydro turbine, that what it is there, it is operated with the induction generator, and we have applied the simple capacitor bank. No complex devices there, a simple capacitor bank is exciting this generator, and obviously when the generator is exciting, we are getting the voltage across the terminals. We are setting the value of the capacitor so that we are getting 440 volt line to line, and we are getting the rated current of the motor at its terminals by putting the sufficient amount of the load. Now, what is that load? The load is reduced by two parts. The first is the VFD. It is the variable frequency drive, which is actually doing the effluent treatment work. And sometimes the load of this drive, if becomes lesser, then the load controller will come into action. So the total load, whatever the voltage control drive and this load controller and VFD are in total giving, will be the load of the induction generator. Otherwise, its frequency will increase and its voltage may also increase. So this is a simple control technology to regulate the voltage load controller by the help of microcontroller. We are sensing the current of the VFD and we are giving it the rated current, whatever the rated current there is. Accordingly, it will do the switching of the DC line of the load controller and extra power will be disseminated. It can be actually utilized for some heating purposes. We can put some fishes or anything aquarium temperature, or it can be do some heating work. But the overall energy what we are getting from the generator should be utilized there. So overall, this type of the thing if happens, so some project work was also disseminated by us, and we can see type of the development were done, and this was the work. And if you see the performance, that what type of the performance we are getting. So from power quality point of view, you have used the power quality analyzer here. In this power quality analyzer, we are getting the total harmonic distortion. THD is a very important for any electrical engineer, what he is generating. So the straight line you are looking in the bottom of the three horizontal flaps, what you are looking are very important. These are the results of power quality analyzer, and we can particularly see, you can zoom it and see it, that the voltage is good. It is line to phase voltage is 215 volt, 240 volt, I think so, like that. And also the current is maintained. And THD we are getting is 4.4%. It is quite good for the rural purposes, depending upon. These are the practical results, and similarly, these are the results which are taken by the Regent oscilloscope, and we can say that the voltage is very sinusoidal, current is also sinusoidal, and it is actually the case for the generator, which is getting the power from micro hydro source. The upper result is for the simulation purpose, and it is the generalized result, which is giving the result for different cycles. So whenever the load of the VFD is reducing, the fourth graph you can see it is increasing, and whenever it is reducing, it is again going to be zero. That means whenever the VFD is not operating, your load controller will again going to switch, so that the second amount of the second graph of the current which is showing is regulated accordingly. If the current we have maintained the voltage and frequency in a very simple manner of the micro hydro. So because the river is constantly flowing in a particular season, and it has the fixed amount of the power, so that power is delivered to the different sources. So this is how we can generate the quality electricity with that. So this is the dynamic performance of the same results. Due to some time lagging, I am not very much paying attention on these graphs, but these also the graph with the practical and the experimental things that can be done, and students can also do such type of the things to abbreviate the results. So in these schemes, they are respecting the self-excitation of the induction generator through fixed capacitors, and they are not disturbing the source anywhere. Source is fixed, generator is fixed, whatever the disturbance in load is happening are maintained accordingly between them. No changes in the load side we are maintaining. And induction generator is always seeing the rated load, so that when the load is fixed, our frequency is fixed and it is remaining constant. For a small capacity, the proposal of the maintaining self-sufficient plant is cost effective, and it is quite justified things. But whenever the things are quite larger, we have to cater different other type of the load, which are actually not the effluent treatment thing is there. Sometimes the load is in the form of you can say the electric vehicle charging, or the constant power load, or you can say the electric motor operation, then the important thing is that we have to regulate the reactive power what we are supplying to the generator, and it cannot be done with a fixed capacitor or the movement of the capacitor. We put the one capacitor and the second time we put the next capacitor, because that is the very minute requirement, minute differences we have to change, and dynamically we have to change all that things. So accordingly, this arrangement, which is the current controlled dual role voltage source converter for real and reactive control or induction autonomous induction generator. In this, you can say that the induction generator is supplied by excitation capacitor, which is a fixed capacitor, and also the topping of the reactive power is done by the voltage source converter. It is a power electronic device, and its DC bus has the load controller, and the AC side is actually keeping the electrical load. So the diagram is itself saying many things, and if you look all these 5-6 blocks, so they are actually giving you the depiction that how the system is working on. Because in case of constant power loads, CFL, they are very difficult for make operating them in the weak systems. Weak system saying means a small generator, it is a weak system. Electrical grid, national grid, it is a strong network. You can run any electric motor or you can switch on off the load, no problem at all. But for the weak generators, we are not having our open hands to put a big load on there, to put the induction motor there. But if we are generating the power, so we have to investigate all these things that the user have to they have to use all these things as their load. How will you say to the farmer that don't use induction motor for your water pumping? How will you say to the people who will going who is putting an CFL bulb in their house, and you are saying that no, my electricity is from micro hydro, don't use the CFL bulb there. So you have to develop the technologies that how it can be done. Because what happens that when CFL load is actually the constant power type of the load, and when this constant power type of the loads come into picture, so their aim is that whenever the current increases, their voltage decreases. The voltage decreases is increase the current. The current increases, that decreases the voltage. And in nutshell, what happens that this phenomenal operation ultimately collapses the generator. We will put the excitation to the generator, but finally they will be collapsed. 5 minutes the generator will run, and then electricity will go out. You will be getting revolving prime mover, but because reactive power is not there, you are not able to generate the voltage. And the solution is actually the dynamic excitation control. Dynamic means we put some device or any device which is constantly giving the reactive power to the generator for constant according to the requirement of load. Induction generator is demanding high reactive power at starting, so it will give high reactive power to the generator also. Otherwise, that induction motor will take the part of the capacitor which it is providing for its own excitation, rather the generator will move on because its inertia is larger. So with that, we will able to maintain the voltage of the generator even then it is operating the devices like induction generator or constant power loads, right? So this is the induction generator, and it is excited dynamically. The diagram is quite similar to the previous one, but here the prime mover is there, but you can see that the chopper, DC bus and STATCOM, just see in the left hand side diagram, the white block, and there is a figure you can see there. In this figure, chopper, DC bus and STATCOM are written. So there are 8 switches are there. So this is 3-phase 4-wire system, and one figure is also shown in the right hand side. In the upper side, there 6 figures are there. So this is 3-phase 3-wire system. So in 3-phase 4-wire, the neutral is also there. So we have to compensate the neutral also. In power system, this is an important issue that neutral currents are also to be maintained. It should be neutralized. But the aim of this complete STATCOM is that it is giving the power to the load controller in case your load becomes lesser, and also the 6 switches are giving the reactive power according to the switches. So you can see the DC bus, there is a capacitor, big capacitor in DC bus, and it will provide according to the switching the reactive power to the generator, so that finally what we are getting is the reactive power which is actually required, right? So this is the scheme, and it will work under indirect current control scheme. We are controlling the current, and current control is almost very good thing for any electrical persons. If you are able to control the current, so you are very much able to do precise control, rather you are controlling the voltage, because you know that current limit is 10 ampere, voltage limit is 240 volt for single phase, 440 volt for three phase. So you have to do larger, and voltage effects are very much poor. The dynamic response of the voltage control is poor than that of the current control. But current control is very sophisticated. The small change in the current will burn your system actually if it is not done properly. VSC in acting as STATCOM meets dynamic requirement of reactive power, and the voltage source converter also offsets the deficit of the connected load by absorbing real power through the chopper and DC bus. So these are the three-phase system and four-phase system schemes that I have proposed or shown to you, that how it can be utilized for micro hydro with electricity generation. And briefly, I would like also to tell you about the control algorithm, because these are very important things. Overall, the computer engineer or the electronic peoples or the control system engineers have the important role to work on the control algorithm. These are the sophisticated things. We have to sense the DC voltage, we have to sense the line current, then we have to check them with the DC voltage. Otherwise, because all the plays with the DC voltage regulation, all the engineers and all the researchers are working to maintain this DC voltage. If there is a collapse in this DC voltage, you will be getting the collapse in AC side also. And its regulation will be done by different technologies. You might have aware about artificial intelligence technologies, neural network, fuzzy logic, and many other methods are proposed by the different peoples to control all these algorithms. To control, here I am using a very simple PI controller. You can use neural network, you can use artificial intelligence, and anywhere which has a fast response. Our aim is that whatever the DC is actually in the circuit should be done fastly to 600 volt, which we want to maintain, so that whatever the current we want should be there. And then we are converting in the DC reference frame. People who are working in the research field might know DC DQ transformation, ABC to DQ transformation, because why we do it for new persons who are not aware about this fact is that you know that controlling of DC motor is very easy. DC motor has armature winding, field winding. You can control armature winding and your motor will run accordingly. The very best thing of the DC motor is the precise speed control. But in the case of induction motor, it is operating with the three-phase AC supply. And AC supplies always have some peak value, then it goes to zero, then it coming again become negative, then zero. So every time with the time function, you cannot find what value at you are. So this transformation actually giving you, this is called the rotating reference frame. For the layman language, I can cite the example that suppose you are sitting in the bus stop, you are sitting in the bus stop and bus is coming. So you will see that bus is coming, it is approaching me and it has gone. Okay. So you cannot touch the bus, even you are not able to touch the part of the bus because it will harm your body part. But now you can imagine the second example. You are in the second bus, which is running parallel to that bus. So you will be able to share your popcorn with a second person who is in the next bus, isn't it? So that becomes the type of DC. This is simply the example in which you can interpret all these things, because this is a complex equation. Full books are available, which will give you the insight about how you can do all these transformations, and all the PLL based technologies are there, which ultimately aims you that exactly how we can convert that DC rotating to the fixed rotating. They are the rotating reference frames. And then we can do our control, and overall we have to develop the switching pulses for our inverter so that we are getting actually the reactive power what is required for the generator to maintain constant voltage. That what it is. And these are the results that the type of the previous results we can see during starting when the system is running. You can see the very big collapse is there, because whenever anybody starts, okay, so he is getting the very big load. For students, I can say, if you are not studying for last 1 month, and on the first day you will find it quite bulky to open the book, but for 3-4 days when you go on studying anything, it will become your hobby and the thing will become steady. Like that happens with anything. If we start any work, new work, sometime it is the transient actually. So that transient is also in the motor. It is presented like this. But when the system is becoming in steady conditions, then all the things are quite stabilized, and the voltage and frequency and everything and the load, everything is switching on and off, and your system is running properly. Because this is the micro hydro system, your power is continuously to the generator. The load is coming in, coming out according to the requirement of consumer. Even then, your generator is giving you full power, giving you full energy, full current. That is what is happening here. So this is also the diagram which we can see. This is the DC side graphs you can see. And this type of the work you can also present by doing some type of the investigation, or how we can utilize this, because certain scopes for further research and investigations are always there in anything we have to do. So this scheme is actually capable to regulate the voltage and frequency in effective manner during load perturbation and its sites. It maintains the healthy voltage profile. It employs indirect current control mode. The system remain in synchronous even after load perturbations, and it is very fast, and it affects the duplication of circuits. Okay, so you can see that how you can measure the power quality, how the load changes. That is the important term for any engineer who is working. And now in a I think few time if it's left, I can throw some light on grid coupling also. Sir, is there any more time I proceed, or we will touch in next time? Hello. Hello.
Yes, sir.
Sir, actually 1.5 hour as you have depicted was over. So
Yes, sir.
we go ahead, or next time we can touch it. I
Ah.
just them in a short time.
As you wish, sir.
Okay, because it is also the part due to some disturbance actually the things were. But okay, audiences, this is actually the grid coupling, and whenever we are talking about the grid coupling, so it is not actually easy thing. We have the grid of very large voltage. We are dealing with 11 kV, we are dealing with 33 kV, and a small generator of 440 volt. When it is coupled, and any disturbance is if occurring there, will burn all the generator. So it is very important and a challenging issues to prohibit all that things, because the large inrush current will be drawn by the source. It will provide the stress on turbine and generator. It is the threat to the grid stability. Intermediate turbine operation with tight bound range we have to operate. Turbine side disturbances may lead to reverse flow of real power. Whatever the power we want to supply to the grid, it can reverse back, and it will be dangerous for the local users. During islanding, transient overvolting of generator may occur. So these are the issues, and something we have to do for that. So for grid, if you want to connect our micro systems with the grid actually, so power electronic converters are one of the key things we have to take into consideration, because they are capable to transfer power in a decoupled mode from one end to other or other end to first user. That means if in your village you have installed micro hydro and the grid is also there, so you use your full power with the local generation. But in case you are requiring the power from the, no bill will come for you, no electricity bill will come. But if you are taking the extra demand, suppose a function is in your village and you want that to generate extra, requiring extra power, so it can be taken directly from the grid. So no such issue that you have to install separate generators like that. So we can use the flexible grid coupling for seamless power transfer from small grid generation. We can use decoupled control of generator to ensure maximum power attraction even during disturbances in turbine side. We can have the critical load support across back-to-back converters, and nano grid for catering the load and treating grid as storage. We can store the grid. See, these are the four important challenges. If I am saying grid as storage, so if I am having extra power from my own generation, I can store that power to the grid. Because we will say to the grid operator that yes, this is a certain 500 megawatts we have given you in the rainy season. Now you supply us in the winter time this 500 watt back to us. So they will charge you no bill. So it is one of the good options. Okay, critical load support. Critical load support is, suppose in any hospital operation theater is there and sometimes the electricity is blackout. So what will happen? So they will not be able to operate that person and he will suffer. In that case, your local generation will supply the power to the load that is on the grid. It is a very good example to see it on that way. So this is one of the scheme if you are able to understand this. So there are the generator side, there is the grid side, and we are connecting them with the help of back-to-back converters, with the help of the load in between. So no load controller actually operation is quite viable here. Whatever the power we are losing in the load controller in the previous section is directly transacted towards the grid, and grid operator will giving you revenue in place of that. If you are in the night times, you are not requiring that electricity supplied to the grid, and they will note that how much kilowatt hour you have given us, and accordingly to the treaty between you and them, they will pay you. So this can be the scheme, and this is how your transfer of the power will take place. During the grid connected mode, your transaction of the power will be taking like this. Whatever the power generated will be given to your local side, and extra power delta P will be transacted towards the grid side. And whenever you are isolated, that means grid is not available. Even you will not imagine that you are getting the power from your local hydro source in the form of a small generator, but you have put in your river. It is giving you supply. So it is type of the inverter with a battery you are installing in your home, or you are putting the generator. It is a very effective solution that you put a turbine, float a turbine on your nearby river, and uninterrupted supply around the clock you are getting with either this type of the things. So these are the control scheme. And if you want to do some mathematical modeling, so we have to consider each and every thing which are the major component here. And again, we can do it with the simulations also. And as far as I have explained the results, so these are the results and outcomes. So thank you. And if anybody want to develop some prototypes, so you have to put some efforts there, and we can always require some things which I have already mentioned. With this, we can develop some prototypes for micro hydro type of generation, or even we can work for the wind also. We have to change the emulators for the lab purposes, and we can see it. These are some hardware sections we can use. And already, as I was depicting, that micro hydro projects are very much coming into picture nowadays, and companies like Tata Power, they are also floating themselves toward micro hydro. See, they have installed 10 kilowatt micro hydro projects there. Ministry of Renewable and Renewable Energy, they have given financial assistance in Kerala to install micro projects. So, but even then, the work is to be required, research is to be required, installations are also there. So all those working in the feedback loops. So the references for this, we have gone through some patent, web portals, technical books, projects, commission projects, and all these things. And these are some requirements to do some things. And if anybody want to ask any question, they can ask. And you can always email me the queries and my mail ID, and whatever the help from my side if possible, I will give it to you.
Anybody have doubts? Please raise your hand. I will unmute yourself.
And you can also email me the questions. I will reply you as best I can. And you can work on this field. This is a interdisciplinary field. Actually, you cannot think that this is only the work of electrical engineers or electronic engineers. Computer programming is very important for microcontrollers and control algorithm development. And the civil work is also involved there. Mechanical work is also involved there. And electrical is important, obviously, because ultimately this is the electrical power. Electronic circuits are very important for control point of view. So thank you very much, sir.
Yes, sir. Sir, thank you, sir. Thank you very much, sir.
Okay, thank you, sir. So
Participants, you have any doubts, you can type in the chat box. The feedback form is posted in the chat box. All of you fill it. Sir, I think there is no doubt, sir.
okay. But for students, you can always work in some of growing technologies, because what is established actually it is okay, but you can also think some more sources which are capable to generate energy, because in future it seems that the big electricity generators will not be quite practical things. Small generation in the form of microgrid, smart grid, they will be actually coming in the system. So it is very important that whatever the source you see, try to employ some power electronics and some your techniques, and try to develop some quality electricity there. Okay, sir. Thank you. So we can leave the session now.
Yeah, okay, sir. Thank you, sir. Thank you very much.
Okay. Thank you.
Participants, feedback link is posted in the chat box. All of you fill it and then you can leave. Sir, you can to be select anything, sir, in the year. Feedback link is posted in chat box. Everyone can fill it and then you can leave. If you are faculty, just you have to be selecting any one of the year. That's not a problem.